Thank you very much for joining us again. We are now going to enter the keynote speech session under the theme Advancing Human-Centric Technology for Smart Future. Before that, I would like to introduce the first keynote chair, Mr. Yuda Nurdin MT. Please welcome Mr. Yuda Nurdin MT.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, all participants, our distinguished keynote speakers, and honorable guests. We would like to thank you for joining us in our exciting keynote speaker session. Let me introduce myself. My name is Yuda Nurdin, and I am from Department of Electrical and Computer Engineering, Universitas Syah Kuala. I will be the moderator for the first keynote speaker session at Virtual International Conference on Computer System, Information Technology, and Electrical Engineering, or COSITE 2021, with the support from the IEEE Indonesian section. I would like to welcome all of you to our first COSITE conference. Thank you very much for participating and attending the conference. We are very much looking forward to exciting discussion and presentation from our keynote speakers and presenters. We delighted that on this conference, we can bring together more than 100 participants on virtual conference, and for more than 7 countries, we have 38 scientific contributions that we will discuss on today's event. It is a unique and fascinating opportunity for us to host this virtual conference, and it brings us great joy and honor to work together with researchers and practitioners from different fields of science and technology background. The COSITE conference took the theme Advancing Human-Centric Technology for Smart Future. We hope that this event will bridging the cooperation and collaboration between the academicians, professionals, and governments to discuss new ideas as a forum to share knowledge, presenting state-of-the-art of a research, discovery of a new technology invention, and building a research network. The COSITE 2021 intends to be a major forum for scientists, engineers, and practitioners interested in the study, analysis, design, modeling, and implementation of computer system, information technology, and electrical engineering, both theoretically and in a broad range of application fields. Our first keynote speaker is Associate Professor Muhammad Ashraf Zorkifi from University Kebangsaan Malaysia. Professor Zorkifi received his bachelor degree of engineering in the major mechatronics from International Islamic University Malaysia in 2008, and PhD in electrical and electronics from the University of Melbourne in 2012. In 2014 and 2015, he was a visiting academic and visiting researcher at the University of Melbourne and MIMOS. He was then appointed as an associate professor at the University Kebangsaan Malaysia in 2016, where he was later attached to the Department of Computer Science, the University of Oxford for 2 years as a sponsored researcher. Recently, he received the Turkish Burslary Fellowship Award for short attachment at the Sabancı University in Turkey. His main research interest in deep learning application in computer vision. His speech today will be titled COVID-19 Screening Using Advanced Deep Learning Methods. I will remind for the audience that after his presentation, I will give the opportunity for our participants to ask questions to Professor Zakifi. Therefore, I would like to encourage our colleagues to use that time frame if you would like to ask any question. Okay. Without further ado, we welcome Professor Muhammad Ashraf Zorkifi to give his presentation.
Okay, Assalamualaikum and very good morning, everyone. I hope that
Walaikum
my
salam.
voice is clear.
Yes, very clear.
Okay, thank you very much, Dr. Yuda. Thank you for a brief introduction. Okay, so without further ado, I would like to continue with my presentation today. So I would like to share my slide first. Okay, is it visible, my slide?
Yes, yes, we can see the slide.
Should I make it a presentation mode? Or...
Yeah,
Okay.
perfect.
Thank you very much. Okay, good morning, everyone. So my talk will be about COVID-19 screening using advanced deep learning methods. So I'll start with a brief on the basic of the what is a COVID-19. I think everyone know about that. It has been infected on our all living for 2 years already. So and then I'll talk about what we call it the transfer learning approach to the deep learning, and then a specific network architecture just for the COVID-19 screening. Okay, let's take a look at the COVID-19, its origin. So I believe that we have passed through a lot of SARS diseases. Okay, SARS is a severe acute syndrome disease, respiratory disease. So it's affect our lung, it's affect our respiratory, which is our breathing mechanism. So it has been like a few mutation of the SARS have been introduced throughout the history. So, but not much of them has become a pandemic. Okay, for example, the MERS, it has become endemics in the what we call in the Middle East. So basically, it's come from the what we called it a animal origin. So it starts from the animals, and there are several animals popular which is linked to the COVID, what SARS in general, which is a bat, camel, or birds. Okay, but for COVID-19, they don't really, what we call it, they don't really find the exact origin of the disease yet. But the most popular, most popular theory is it comes from the bats and it starts spreading in the wet market in Wuhan. So yes, from then it affects humans. Okay, so actually more than not 4.2. I think the recent numbers is a 4.5 million stats on the COVID-19, and that's the countable one. We have a lot of numbers which is not countable. I mean, the hidden cases in certain countries. So actually, the real number will be much higher than that. Okay. So this version of SARS, we call it a SARS-CoV-19 too, and there have been a lot of various mutation on that. And the recent one, which is very deadly, is the Delta variant. I think most of the countries has been handling the COVID-19 cases quite well. I mean, the numbers doesn't really spike, except for the first version. But when we encounter the Delta version in the early of 2021, a lot of countries cannot manage it, especially my country, Malaysia, because of it is much easier to transfer to other people. Okay, we used to say that, okay, if you have like a distant 1 meter from other people, you might be safe from getting infected by the disease, but that's not really the case for the Delta variant. So there is not much we can do about that. So it is hard to constrain ourselves to be further from other people. So yeah, the best solution people have been taking is what we call it a vaccination. Okay, I believe that a lot of countries have done very well in the vaccination, and most of the countries in the world have passed the 60% number of all their adult populations. So currently in Malaysia, we have surpassed 80%. So we are treating that as a normal flu. So it doesn't treat it as a pandemic anymore. It becomes endemics. So we can still come out, but we need to adhere to a certain policy, such as still wearing the mask, and you still need to distance yourself from other people's, and you still need to log in into one app in which in our country is called My Chapter. There are a lot of similar apps in other country like Saudi Arabia, Tawakkalna. So a lot of similar apps. I'm not quite sure about Indonesia. What's the names of the apps? But it just to track the interaction between people. So hopefully that we can track. Okay, you might getting the high possibility of getting the disease. Okay, so unfortunately, we have seen the trend. Okay, rate of the vaccination is monopolized by the developed country. So during the early stage of the vaccinations, it is hard for Malaysia actually to get the good numbers of vaccines. So we do really only get the big numbers of the vaccine in April or in May 2021. So, but as a comparison, in UK in June they're already being allowed to go free without any mask anymore. So we have lack around like 6 months, but that 6 months is very crucial because if we take a look at our mortality rate, so actually we have more than 20,000 deaths, but 15 to 16,000 of that happened during the last 6 months. So it's very crucial for our country at that time. So yeah, we need to have a good vaccination, but we also need some sort of screening methods in order to, in order to detect the disease early. Okay, but this is the unique about COVID-19, where you can't really, there is some incubation period for that disease. So you can't really detect it or see the visible symptoms in the early stage. So in Malaysia, we follow the WHO approval testing, which is a reverse transcription polymerase chain reaction. So this is usually a nasal swabs in which you swab your, what we call it, nasal saliva or nasal fluid, and you put it into the under the microscope and to find whether you have the virus or not. Okay, but it is very expensive in Malaysia. It is considered expensive. And now, if you want to travel by aeroplane, you need to spend around 200 ringgit per person just to do the test. Okay, and then we have like RT antigen care, RT antigen test, which is a rapid testing. There are two versions of them at the moment. We have a nasal fluid and saliva, but most of the airline doesn't really, what we call it, approve the saliva parts of the testing. So you still need to swab using your nasal, and the test is quite cheaper, which is a 30 ringgit. But there is a one thing that you need to be aware about this test. It only detects quite late. I mean, not quite late. I mean, once the numbers of virus has passed through some threshold value, then it will be detected. And it cannot, okay, RT antigen test cannot detect the severity level of the disease. So it's either you have it or not it until, the certain numbers of the virus exceed certain numbers of the density of the virus, and then, okay, we detect the COVID-19. So one of the things that we think, okay, why don't we use the existing, what we call it, existing modality, such as X-ray, MRI, which is available throughout the world, throughout the countries. Okay, so that's why we are looking at the X-ray based screening. Okay, so by using X-ray screening, we will be able to perform immediate isolation of the quarantines, and it is relatively cheap, which is 50 ringgit in Malaysia, which is not that much different compared to RTK antigen, which is 30 ringgit. So it's still a fast results. You can get an X-ray within 20 minutes, and you can get the film within, we don't use film anymore actually, just take a look at the screens, and then you can identify the severity level of the disease of the COVID-19. Okay, but the thing is, it is very hard to really distinguish the level or the existence of the COVID-19 just based on X-ray. And especially you have a various types of X-ray machine throughout the world. So sometimes you get a high resolution ones, and sometimes you get a low resolution one. Sometimes you just screenshot on the exact body of your torso, and then sometimes you don't really align it well. So there are a lot of challenge in doing an X-ray based screening. So that's why we are proposing or take a look at the automated deep learning approach to a COVID-19 X-ray screening. Okay, so I believe AI or machine learning has been a very popular topics for the past few years. So before 2012, the conventional machine learning, which is the neural networks, the SVM, the genetic algorithm is the most popular research path. Okay, and then came 2012, in which with the introduction of the LXNet and with the introduction of ZFNet, so we came into the deep learning era, in which it allows you to combine the feature extraction and the what we called it the task based idea classification, regressions or segmentations into a one end-to-end modules. Okay, you don't really need to handcraft the features anymore. You can actually train it incompatible with the classification or regression modules. So that's the thing. The optimal features works much better compared to the what call it human-based what call it designs. Okay, so that's the comes the deep learning era. Okay, in 2012. So it's actually surpassed the previous techniques very well. I mean, as you can take a look at the slides, okay, in 2012, in 2011, there is a what call one competition, which is ImageNet. So in ImageNet, we do a classification competitions. So before 2011, the error rate is quite high, which is 26%, which is 1/4 of the images will be wrongly classified. Okay, and then comes 2012 with AlexNet, the error has been reduced a lot by to 16%. There's a big jump, which is 10%. So in 2015, it even surpassed our human capability. Okay, why? We said that the human can't reach 100% probability because in certain cases, even us, we will wrongly classify some of the images. Okay, for example, in this case, it's easy. Okay, this is for sure. It's not a dog. It's a cat, right? But how about this case? Is it a cat or a dog? Okay, anyone can try to answer. Is it a cat or dog?
I believe that it is a cat, probably.
Okay, some of you might answer it is a cat, some of you might answer it is a dog. Okay, but the truth of the DNA is a dog.
Oh,
Okay,
oh,
okay,
dog. Okay.
that's a one good example why
Yes,
we
yes, yes.
we
Okay.
we can't really achieve the 100% accuracy in the classification. Okay, so this is the sample in which it's even difficult for human to identify it based on the image alone. Okay, okay, there are several applications which transcend human capability. Okay, in PepsiCo they have apply a vision approach in order to ensure their product in a very homogeneous states. Okay, the what we call cekedih in Malaysia, the jajan or cekedih in Malaysia is a very nice color in a very homogeneous shape. Okay, and that's actually surpass human controllability. Okay, and then we have also heard about AlphaGo. I think there's this one is quite popular in Korea. There is a what we call it Gosido, if I'm not mistaken, the guy. Okay, he's a world champion, but he also lost to the AlphaGo for quite several games. And then, okay, this is quite interesting. Things are very difficult to what we call it, do it manually. People are doing simulation a lot. So one of them is the protein foldings. Okay, so in this area, so they have managed to find a new drugs, to find a new components of the pharmacies of the medicines in which they help us to introduce a new. Actually, one of the things that allow us to perform a faster rate of producing a vaccine for COVID-19, one of them can be attributed to the advancement of the intelligence system. Why? Because previously, in order to identify all the proteins, it takes a lot of time. So now they can identify the COVID-19 protein much easier, and we can produce the vaccine at a faster rate compared to the before. Okay. So even in gaming, actually they are defeating us at the moment. But bear in mind, all this application is a very specific application. So it is not a general intelligence. We human, we have a general artificial intelligence in which we are not constrained to some small applications. Okay. For that machine, it is good only for that particular things. Okay, so they don't really have a general capability. They have only a specific intelligence which surpass human for that particular task. Okay, so there are two things that enable the application of deep learning, which is the big data, and then the second one is the GPU. Okay, the parallel processings. Okay, you need big data because previously in machine learning approach, okay, once you supply a machine when the network is still not deep, once you supply a certain numbers of data, it will not improve your accuracy anymore. I mean, the performance of the network doesn't increase anymore. Okay, but with deep learnings, the threshold is much higher. You can improve it much higher compared to the conventional machine learning. So you need big data, and for sure you need the GPU. Okay, I believe that parallel processor is a very big things, even in the mining, the Bitcoin minings, not the Bitcoins, the cryptocurrency mining. Okay, actually it is very hard for Malaysian to buy a new RTX 3090 now, because most of them are bought by the cryptocurrency miner. So why? Because it allows you parallel processing to process the what call it the blockchain. Okay, but in our case, we need it to process the training phase. Okay, the training phase of the deep learnings. Okay, I mean the inference state. Yeah, we can do it relatively fast, but during the training stage, it is more crucial to have a parallel processor. Okay, I believe that this is just a introduction. Okay, we have like actually what we call it three ways of three popular frameworks of the deep learnings. Okay, the first two is convolutional neural networks and the recurrent neural networks. The convolutional neural networks concern on the spatial relationship of the data. Okay, the recurrent neural network concerns on the temporal analysis of the data. The data is in the temporal forms, in which is there is a subsequent or consequence of each data. There is a relationship throughout the times, while in the convolutional neural network is more toward the spatial relationship. Okay, the third one, we have also the framework of the what we call it reinforcement learning, but that's a different one. So we will talk only about the convolutional neural networks in this case. And okay, I believe the convolutional neural network is just a filter in which you apply filter to the images, but the filter is the weights of the filter is being trained throughout the big data. Okay, big numbers of training data, and you come out with the optimized filter. Okay, not just one, you have a multiple filter for each layer, and you have multiple layers of the deep learnings. Okay, for example, in 2012 we have what we call it LXNet. I think LXNet is a 5 layers of convolutional neural networks. Okay, 5 layers convolutional neural networks. So we have 5, not just 3 by 3. We have a different numbers of kernels, but multiple filters for each layer and multiple layers. So there's a big numbers of filters. Okay, for sure you need a big numbers of data to train it. Otherwise, it's going to become a underfitting or overfitting problems. Okay, so this is some example of the feature, what we call feature maps or the resolution maps that we come out from the filter. We extract from the filter, and then recurrent neural networks, it tries to link the weights throughout the temporal data. So you pass through it into a hidden node several times, and then pass it through several layers or several inputs. So you can have it in that way, but not much of the recurrent neural network has been used for the COVID-19 screening. Okay, most of the methods focus on the convolutional neural networks. Okay, we have two parts of the convolutional neural networks or deep learning approach to the COVID-19 screening. Okay, the first part is pre-trained models, in which you use existing model that have been used for other application, and you transfer into for the application of the COVID-19 screening. Okay, the second one is there are several researchers research or design a specific convolutional neural networks just for the sake of the COVID-19 screening. Okay, so let's take a look at the first few screening pre-trained models. Okay, so most of them are quite recent because COVID-19 is a very new disease. So most of them either were introduced in 2020 or 2021. Okay, so I think Pandit et al. The works by Pandit et al. Was introduced in 2020. So it is one of the early works. So they have used pre-trained VGG and VGG16. Okay, we have a several variation of VGG16. We have a short version, which is a VGGM, which is the for mobile application, and we have a longer one, VGG19. Okay, so VGG19 or VGG architecture is a very straightforward of the CNN. They don't really apply any feed-forward application, or they don't apply any skip connection. It's just a multiple layers of convolutional neural networks, which is then flattened into an array of vector, and passed through a dense connection. Dense connection is just a MLP connection, which is a multi-level perceptrons. So they have 3 layers of multi-level perceptrons. Okay, so they apply okay, at the end I will share the performance different all of these methods. Okay, so let's take a look at just the architecture. Okay, and then Panwa et al. Also introduced the same architecture, okay, but they use a lesser numbers of dense connections, okay, the latter parts, the classification parts, okay. And then we have Loy et al. Okay, Loy et al. Use a residual networks architecture, which is a ResNet 18, which is the lowest version of the ResNet. Okay, we have a ResNet 51, we have a ResNet 101 or 102. I can't remember the exact numbers, but we have a higher numbers of ResNet. But why they only use the lower version of the ResNet, similar to the VGGNet? Because in the early stage of the what we call it, in the early stage of the development of the deep learning based COVID-19 screening, we don't really have much extra images. Okay, you can't use very deep networks with a very small training samples. So that's why they are using the shorter version. Okay, actually they have tests on the longer version, but they found that the shorter version works the best. Okay, but they also have applied the residual network, which is a skip connection, in which you pass through the previous pass through a skip connection towards the what we call it feed forward to the future layers. Okay, and then they combine it by using addition operations. Okay, there's 8 skips connection in their architecture. And then Narin et al. Has analyzed several architecture of the ResNet. Okay, they even test the highest the deepest ResNet architecture, which is ResNet 152, and they even have tested on the Inception V3 and ResNet V2. Okay, Inception is the what we call it architecture that allows you to have a several kernel sizes with several groups of the convolutional filters. Okay, previously ResNet we have a we have a variable numbers of kernel sizes, but it's still same kernel. I mean same size of kernel, 3 by 3 or 5 by 5. Okay. By Inception Net, we have 3 by 3, we have 1 by 1. So there are multiple types of the kernel sizes in which you combine it at the ends. Okay. They have several layers also. Okay, but still they found that the simplest model produced the best result at that time. Okay, but I have done the same thing. I have construct their architecture and tested with a large numbers of data, not exactly using their output, but taking their architecture and take a look at the performance by using large data. But during at that time, last year, they still run with the limited numbers of the extra images. They found that the ResNet 50 is the best perform architecture. Okay. And then they have the works by Khan et al. Okay, Khan et al. Using exception architecture. So exception architecture is a very large architecture. Okay, which is very large, 80x million parameters. So in order to train exception architecture, it takes a lot of times because you have like multiple layers, multiple units of 3 layers convolution, which is 720x 720x filters. Okay, that's a very large number and it's a slow process, but they have used depthwise convolution rather than the normal convolution in order still to reduce it without using depthwise convolutions. Okay, depthwise and pointwise convolution is a factorized version of the convolutional standard convolutional neural networks. I mean, okay, you partition them into two separate entity, two separate groups, which is a depthwise convolution and a pointwise convolutions. It's a very slow computation, but with that depthwise, it is a still slow architecture. Okay, but without depthwise, it's going to take a longer time. So Khan et al, but it's a unique. They also apply a residual skip connection and a residual skip connection with the downscaling. Okay, they apply also convolution in certain residual skip connection to downscale the feature maps. Okay, and then we have a COVID diagnosis net. Okay, diagnosis net is based on the what call it SqueezeNet architecture. Okay, things unique about SqueezeNet architecture is apply a squeeze and excitation schemes, which is called a fire modules. Okay, so in SqueezeNet, you squeeze, you are using two types of convolutional filter, which is 3x3 and 1x1s. Okay, and then they also apply a group convolutions. Okay, what we meant by group convolution means there will be a one that works the trunk sets, and the trunk sets will be divided into two categories and not two groups, and that each group will not interact until you completed the convolutional process and combine back at the end. It will be combined at the channel groups, which is the last layer. And then, okay, the unique about their work is they have done a Bayesian optimization. Okay, they have done a Bayesian optimization to optimize the hyperparameter settings. Okay, we can have like, okay, there are two popular approach to what we call it hyperparameter settings, optimal hyperparameter setting, which is a random or grid search. Okay, but they have done through a Bayesian optimization, which is by using a random search. Okay. Okay, that's some examples of the COVID-19, what we call pre-trained models. Okay, it is a model developed by other application and applied for the COVID-19 screening. Okay, and then I would like to introduce the first architecture, which is a Corodet. It's called Corodet. Okay, Corodet is a very straightforward, similar to VGG nets, but rather than 5 layers of convolutional neural networks, they have used 8 layers convolutional neural networks. One unique features about them is they are using repeated downsampling and upsamplings. Okay, you repeatedly downsampling, upsampling for several layers. Okay, but I found that that's not a very good architecture once you apply in a very large with a very large training data sets. And as you can see later on, it works. The performance is the worst. Okay, and then we have a works by Gilani et al. Okay, rather than using a 3x3 kernel sizes, the guys, I mean the teams have used 5x5 kernel filters. Okay, 5x5 throughout the layers. Okay, multiple layers of 5x5. But remember that if you are using TensorFlow or PyTorch, the optimal kernel size is 3x3 because TensorFlow has said that, sorry, they have used they have optimized the performance of the TensorFlow for 3x3 kernel sizes. So when I try to implement the 5x5, yeah, I found that it is relatively slower. Okay. And then we have a dark COVID nets. Okay, dark COVID nets, it is what we call a variation of the SqueezeNet architecture. Okay, still using squeeze fire modules. Okay, but they have implement 4 units of triple modules. Okay, a bottleneck design. So if we have a bottleneck designs, the numbers of filter in the first layer is large, and then you have a small numbers of filter, and then the large numbers of filter again. So it's bottleneck or glass shape. So you reduce the numbers of filter in the middle layers. Okay, and it's, I mean, the reason for having that types of architecture is to what we call compress the feature to a smaller latent variables, and the main advantage of this model is you have a very relatively smaller numbers of parameters, which is 1 million somethings. Okay, remember that the exception net is 88 million, so that's much larger. So if you want to use your deep learning architecture in a mobile applications, for sure, 88 times more will require a lot more computational times rather than the 1 million parameter computational times, right? So we have also like COVID nets. So the unique about like COVID nets is a very low, what you call it, is a very light model that uses less than 1 million parameter, only 841,000 parameters. Okay, the way they achieve this networks is they are using depth-wise and point-wise. A lot of them depth-wise and point-wise, except for the first few layers. Okay, why when we find that still when you apply a depth-wise convolution for the later layers, you still using the full convolutional layers during the first few layers. I found that if you use straightforward using the first few layers using depth-wise, there will be a lot of information loss at that time. So that's why we don't really apply directly depth-wise in the first few layers. Okay, I think I'm running out of times. So there is a COVID XNet. Okay, the advantage of this COVID XNet, there will be several layers of what we call it parallel dilated convolutions. Okay, dilated convolution is a different types of convolution that allows you to have a sparse sampling of the kernel. Okay, the usual kernel is 3 by 3 or 5 by 5, so there is a dense connection. So if you use a dilated convolution, there will be a space between the kernel. Okay, you do a sparse samplings. So they have applied several sparse samplings, and then the last networks, which is quite recent, 2 months ago, is a residual shuffle net. Okay, residual shuffle nets combines all the residuals and the concatenation, which is the dense connections. So they have also applied group methodology and then shuffle it between the groups, and it works the best at the moment. Okay, let's take a look at the performance. And then okay, the lowest performance is the produced by the Hussein et al, which is the Corodet. Okay, when you do some sort of the downsampling, upsampling, downsamplings, you actually playing with the smaller set of feature maps, and then you upsample it. You don't really gain a lot of information, but you reduce it again. So that's why Corodet works the worst, and yeah, residual shuffle nets works the best in our case, in our test bed, which is more than 4,000 extra images. Okay, I think that's all for me because of the time limit. Thank you very much. Thank you very much. I would like to pass back to the Mr. Yuda.
Thank you very much, Professor Zulkifli, for your compelling presentation. We will next move to question and answer session. I would like to invite or to give our participant an opportunity to ask Professor Zulkifli. Please raise hand if you would like to ask question, please.
I have a question.
Okay. Okay, Dr. Khalil, okay.
Okay, thank you very much. Thank you for the very interesting topic, Professor Zulkifli. I'm Khalil Mukhtar from Universitas Shah Kuala. I have two questions. First, during the experiment on this field, are you encountering some data set challenge, for example, imbalanced data and so on for training the model for COVID-19? This is the first question. And the second one is, from the industrial point of view, in your opinion, which part are their concern? Whether they expect a lightweight system, which has good accuracy, but at the same time, also very fast for inferencing the testing data, or how? Because, for example, sometimes we found that the trade-off, right, more complex architectures will need more time to train the data, and another challenge. So I think this is the question. Thank you very much.
Okay, thank you very much, Dr. Khalil. Okay, the first question is regarding the data sets. Okay, when we do these experiments, we found that okay, in the early stage, for sure there will be more. Okay, we have tested in on the several categories, which is okay. COVID-19 is considered as a pneumonia problem, so we have also test on pneumonia other than COVID-19. Pneumonia, pneumonia. Sorry, pneumonia. Okay, pneumonia. Okay, other than the COVID-19. So COVID-19 is a subset of the pneumonia. So we want to distinguish between the normal pneumonia can be caused by other than virus. Okay, COVID-19 is a virus based, and pneumonia have two branches, which is what we call bacteria based and virus based. Okay, we lump them into one category. Okay, when we found the early stage, we don't really have much data set for the COVID-19, and then at that time the way we increase the numbers of the COVID-19 is by using generative adversarial networks. So we create a synthetic data sets of the COVID-19 in order to boost up the numbers of the X-ray images for that particular. For sure we will have a data imbalance because COVID X-ray screening, I mean X-ray films for the COVID-19 is still in the low numbers. Okay, and then later on, yeah, when we tested on the newer versions, we have more than enough for the COVID-19 cases. Yeah, it has been like 1.5 years. At that time, we have more than enough data, but still we are using GAN to boost up the numbers of the training data. Okay, and then the second question, okay, in the what we call it the industrial perspective. Okay, when we talk industrial perspective, yeah, that's a thing that very different compared to the what we call it to the academic vision. Okay, when in the academic settings, we only concern on the accuracy. We only concern on the accuracy so that we get a good accuracy, we can publish it. But that's not the case in the what we call industrial settings. Okay, if you have like a 95% accuracy with a 96 accuracy, industrial will grab the 95 accuracy if it can perform much faster compared to the 96 accuracy. But for sure, there will be a low threshold in which it works. Okay, for example, the RTK antigens, the return, I mean, the most of the kits return 92% accuracy. So we need to take a look at the benchmark. So as long as we have a good networks that can surpass the RTK antigens accuracy, for sure we can apply it for the I mean the X-ray screening for the normal accuracy, for the normal rather than the RTK antigen, which is a 92%. Okay, we can go for the 95% or 96%, but in the industrial setting, they want to have a lightweight model and a faster. Okay, even if you have a lightweight models, you might have a very long computational times. For example, the depth-wise convolutions. Okay, depth-wise convolution allows you to have a lightweight model, but the computational time is actually much longer compared to the standard convolutions. So you need to trade off between the numbers of the memory storage and the computational times. Okay, as long as surpass the minimum threshold, which is the 92%, and you need to have to make sure the computational time is faster and the memory storage is lower. Okay, thank you very much. I hope that's answered the question.
Thank you, Professor Zorkifi. Okay, maybe Dr. Khalil, do you want to respond or have any questions?
All clear. Thank you very much.
Okay, thank you. Is there any other participant who would like to ask Professor Zorkifi? Okay, there's Alim, yeah, Mr. Alim, I think. Yeah. Okay.
Yes.
Yeah, you can ask the question, please.
Okay, thank you, moderator. And it's a very good topic talked by Professor Zakifi. I have a question about actually, I see from your slide you mentioned about the VGG, right? And then the ResNet, and then the other architecture that apply for the image like the X-ray. Based on your experiment, did you try to use the kind of the pre-trained model? Because as we know that like the VGG and the ResNet, they have pre-trained model, right? With the trained with huge image data, and then try to apply this one into the like small image, like we mentioned, because the Dr. Kali mentioned before, imbalance data. So if we have this kind of pre-trained model with a strong weight, and then we will have the robust model for the specific type, like you mentioned about the COVID-19. Okay, thank you, Professor Zakifi.
Okay, we do use the what we call the pre-trained models, okay, which is the based on the ImageNet training. So we use the pre-trained models, and we do transfer learnings. Okay, we train in on we replace the dense layer connection with only 3 layers connection, because you can only take the pre-trained model of the CNNs, and then we replace the last layers of the dense connections. Okay, thank you very much.
So based on your experiment, compare with the, if you use the pre-trained model and without the pre-trained model, which one is the get a good result on that kind of case?
Okay, for sure. The with the
Pre-trained
pre-trained
model.
model works the best, because
Okay.
without pre-trained model, it is what we call it. We will encounter a lot of what we call it overfitting problems, because the numbers of the data is still relatively low. Okay, even at the moments we are using 1,400 per class. Okay, 1,400 per class. If you are using exception nets, at X million parameters, so you can't really actually to train it well without pre-trained models. So that's why if you take a look at the new the what you call specific convolutional neural network architecture, which is designed just for COVID-19, most of them are very lightweight. Most of them are very small parameter, small networks. It's a deep learning, but still relatively complex compared to the ResNet or DenseNet, which is a 200 something, so 152 layers. Okay, most of them are less than 100 layers. Yes.
Okay. Okay. Thank you, Professor Zakifi.
Okay, thank you, Dr. Alim.
Okay, thank you, Mr. Alim. Okay, we still have spare time. If anyone would like to ask, okay, we have Mrs. Roslidar. You can, if you would like to ask question to Professor Zulkifli, please.
Okay, thank you, Pak Yuda. Prof, I'm doing research myself and using deep learning, and I still have question. How can, in which term the model called lightweight? I mean, that is it like the convolutional algorithm or the learning parameter or what? Because I'm looking for the reference that cited explicitly about the criteria of the lightweight model. I couldn't find any of that. Could you please help me? But thank you very much.
Okay, thank you for
Okay,
the question. Okay,
okay, thank you
please,
for the question.
Professor Zulkifli.
Okay, thank you for the question. Okay, okay. This is actually, there is no what we call it general agreements on what's the limit for the lightweight parameters. Okay, but from my experience, I can say that if it's less than 10 million parameter, it is called lightweight. But lightweight doesn't necessarily mean it's a fast computational. You need to distinguish between fast computational architecture and a lightweight. Sometimes a lighter version of the networks might require more times to compute the convolutional, like such as stepwise. So if you partition into several groups, for sure you have a lightweight version, but it is not, doesn't mean that it is fast. Okay, but for lightweights, it's just on the memory storage, which is less than 10 million parameters. Okay, because most of the what we call mobile-based applications, okay, 10 million parameter, I can't remember. I think it's a 50 megabyte somethings in order to store the what you call the weights of the networks. So 50 megabyte, yeah, it still looks low, but when you compute it, it's going to take a lot of time. So if you are using mobile-based application, I hope that's answered the question.
Okay, I hope it answers your question. Maybe we can use deep learning to classify it about lightweight or not lightweight also in the process. Okay. So we can use machine learning to make criteria for lightweight or not. Okay, due to the time restriction, we can only accommodate a number of questions, but I believe there will be any other opportunity in the future to exchange ideas and discussion with Professor Zulkifli. Therefore, I would like to give a big appreciation to Professor Zulkifli to his presentation and insight. And we are looking forward for any research collaboration in the near future with Professor Zulkifli. Thank you very much, Professor.
Thank you very much, everyone, Dr. Yuda especially. Thank you.
Yeah,
Very
thank
much.
you.
Thank you for inviting me, the organizer.
It's an honor for us. In the name of the committee, we would like to thank you, Professor Zulkifli, and we will move to the next event with another keynote speaker. I will hand over to our MC for our next session.